In this section, we are going to learn the product rule to find the derivative of the functions. So again, we are not going to go much into the proof of product rule, but how to utilize it. So if we want to differentiate two functions, product, both of them are differentiable, and we want to find the derivative of the product. The formula says if we have to differentiate product of two functions, let's name it as first function and second function. Okay, that's easy to remember. So the product rule says you differentiate the first function, the second function stays as is, plus the first function stays as is times the derivative of the second function. So in general, the formula is written like this. Derivative of product of two functions is equal to derivative of the first function f prime, derivative of the first function times the second function as is, plus the first function as is times the derivative of the second function. This thing is called product rule. So we're going to practice a few questions now to learn this. Let's try to find our first example from the notes. So as you notice, this is product of two functions. You can name this first function and this second function. Okay. And let's write down the product rule here on the side to remind you. If we have product of two functions, derivative of y is first function's derivative second as is plus first function as is times the derivative of the second function. Let's use that. Y prime derivative of the first function. First function is this times the second function. Do not do anything to it, just copy it, plus the first function as is times the derivative of the second function. Okay, let's look at this. What is the derivative of this? Derivative of 2 is 0. We don't need to write it. Plus negative 1 comes down. X the power negative 1 minus 1 is negative 2. And the second function is written as is. Plus first function is written as is times this derivative of second function. 3 by 2 comes down. Power 3 by 2 minus 1. So we have negative 1 by x squared, x to the power 3 by 2 plus 1 plus 2 plus x to the power negative 1 times 3 by 2, x to the power 3 by 2 minus 1 is half. We can either leave it here or we can distribute it inside. Negative x3 by 2 by x squared plus, actually that's also going to be negative 1 by x squared plus, this also will distribute inside 2, this time this and this time this. 2 times 3 by 2 is just 3, x to the power half plus 3 by 2. When we multiply this with this, powers add, okay? So x negative 1 plus half. This is going to be negative 1 by x to the power 1 by 2 square plus 3x to the power half plus 3 by 2. This is x to the power negative half, so that's basically it goes in the denominator. Okay, so this is, because this is negative half, negative exponent goes together. Now this term and this term are like terms, we can add them. What do we have? Negative x squared plus 3x to the power half. 3 by 2 minus 1 is half. So half x to the power 2. By taking these two like terms, we get this last term. Okay. So this is your final answer after simplifying. Let's do next example from our notes. H of s is equal to s cubed plus 2s plus 7. So that is your first function. This is your second function. If you remember, if we have product of two functions, then the derivative rule is, product rule is, first function's derivative, second as is plus, first function as is times the second function's derivative. Okay, so let's write it down. We need to find derivative of h with respect to s. So derivative of the first function with respect to s, which is s cubed plus 2s plus 7 times s4 plus s squared minus 3s plus the first function as is times the derivative of second function. Let's do the derivatives. Derivative is done using the power rule. You guys know the power rule. Derivative of x to the power n is nxn minus 1. Power comes down, power 1 less. So s cube's derivative would be 3s squared plus, here the power is 1, so 2s's derivative is 2. Constant's derivative is always 0, so we do not need to write that, times s4 plus s squared minus 3s plus, this is written as is, times derivative of this is 4s cubed using the power rule again, 2s minus 3s's derivative is 3. So either we can just leave it here, or if the book asks you to distribute, you can simplify and then get the answer. I think I'm going to leave that to you. I'm going to do one more example. Let's do this one. In this case, this is your first function. This is your second function. One more time, your rule is if we have product of two functions, derivative of y with respect to x is first function's derivative, second function as is, plus first function as is times the second function's derivative. So let's work on it. Derivative of this. What is derivative of root x plus times the second function as is plus the first function as is times the derivative of the second function. Okay. Do you guys remember from your last section of derivative formulas that derivative of root x can be done using the derivative of the power? Basically, this comes up to be 1 by 2 root x. That's how you can remember it. Okay. So derivative of root x is 1 by 2 root x. So you're going to use that times plus root x as is. Derivative of x is 1 plus 2 root x's derivative is 1 by 2 root x. Now this is gonna distribute inside. So we're gonna say x by 2 root x plus, when this multiplies with this, it's the same thing, just 1. This multiplies with this, we get root x This multiplies with this, root x cancels and 2 also cancels. We're going to just get 1. X by root x is, we're going to only left with root x. So root x by 2 plus 1 plus, actually 1 plus 1 can be written as 2. And these two are the like terms. Coefficient here is 1, coefficient here is 1 by 2. You can add the coefficient. So 2 plus 3 by 2 root x. That's the simplification. So it's just basically you need to identify when to apply the product rule. The product rule applies when we have two functions product. It's first function's derivatives times the second as is plus first function as is times second derivative of the second function. You write that, apply the derivative formulas as you know, and then simplify and get your answer.